This is the H3PO4 Lewis structure, phosphoric acid. For H3PO4, we have a total of 32 valence electrons. When we see that we have H's in front of a polyatomic ion, we know that the H's are going to be attached to the outside of the oxygens to form OH groups. So we'll put phosphorus at the center, that's the least electronegative, and then we'll put OH groups. There's 1, 2, 3, and then we have an additional oxygen here. We'll put 2 electrons between atoms to form chemical bonds. We've used 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. If you look closely, you can see that each of the atoms has a full outer shell. The hydrogens each have 2 valence electrons, and the oxygens and phosphoruses each have 8 valence electrons around them. We've also used all 32 of our valence electrons, so this looks like a pretty good Lewis structure. However, we really need to look at our formal charges. Phosphorus here is below period 2 on the periodic table, that's row 2, and that means that it can have an expanded octet, more than 8 valence electrons. So let's take a look and see what our formal charges are for H3PO4. Phosphorus has a formal charge of +1, and this oxygen here has a formal charge of -1. All other atoms have a formal charge of 0. We'd like this to be as close to 0 as possible, so what we can do is take and form a double bond with this oxygen and this phosphorus and recalculate our formal charges. By forming this double bond right here, we now have a formal charge of 0 on the phosphorus and on the oxygen. Everything else has a formal charge of 0. We're still using only 32 valence electrons, so this is the most likely or plausible Lewis structure for H3PO4 because the formal charges are closer to 0. So that's the Lewis structure for H3PO4. This is Dr. B, and thanks for watching.